Oh, well, hello. Welcome. The derivative of the natural logarithm. Realized I forgot. I started the year putting pictures in here that are all special. Now we just go to the derivative of the natural logarithm. So let's just get started without much fanfare or ado. The derivative of the natural log of x is 1 over x. It is. Trust me. It's 1 over x. The derivative of the natural log of u is 1 over u du dx. That's the chain rule. Okay, and a lot of times the easier way to say that is the derivative of the natural log of u is u primed over u, because derivative du dx is u primed, and 1 over u is 1 over u, and if we make that nice, u primed over u. So that's the way that we sort of remember derivative of the natural log of u primed over u. Let's see what that looks like, shall we? We want to know what the derivative of this particular little thing here is. There is the pen. Blue today. So the derivative of y equals the natural log of 3x squared plus 5. Remember, the derivative is u primed over u. So u primed over u, this y primed is going to be, let's do it up, it's always going to be some sort of fraction. Well, the u is 3x squared plus 5. And then on the top, we put the derivative of 3x squared plus 5, which is 6x. Okay, u primed over u. There you go. Okay, derivative of the natural log. Ooh, this one. So first we're going to have to simplify, because we don't want to necessarily, we could do the u primed over u square root of things like that, but let's make it nice and use the properties of natural logs. So we know that that's the natural log of x plus 5 to the 1/2. And we also know that we can bring the 1/2 out in front as an exponent to an exponent. You just multiply the exponents together. And logarithms are just fancy exponents. All right, so now if I want to know the derivative of this, y primed, well, the half is just a multiplier, so I'm going to leave the half there. And I'm going to do u primed over u, so u is x plus 5, and the derivative of x plus 5 is 1. So this just turns into 1 over 2 times x plus 5. Soak that in for a second. Properties of logarithms, boom, boom, u primed over u. Derivative of the natural log of the cosine of x. And the reason it's an absolute value is because the natural log can be negative and the cosine goes negative, so we always have to consider that we would want to get some sort of an error. If you tried to graph natural log of cosine, you'd get some error messages here and there. So we just do the absolute value of it. So x is the natural log of the absolute value of the cosine of x. It's not going to be that big a deal as we move forward. So y primed equals u primed over u. So u primed over u is, well, the u part is cosine of x. What's the derivative of cosine? That's right. Negative sine. Okay, and we all know that sine over cosine is tangent. So it's the negative tangent of x. Okay? Remember that as we move in the other direction. Helps us with some antiderivatives. Ooh, look at this one. This looks like product, right? 5x squared times the natural log of 3x plus 5. So we're going to have to use the product rule to do the derivative. Okay? And we all remember the product rule because it's burned into our brain. The first times the derivative of the second. And the second's a natural log, so we've got to do a fraction thing, u primed over u. 3x plus 5 on the bottom, derivative of that on the top, plus the second, and that's the natural log thing, and I'm just going to, we'll just do it that way. Natural log 3x plus 5, and the derivative of the first is 10x. Okay? So, I probably would make this 15x squared over 3x plus 5 plus 10x natural log 3x plus 5 and call it done. Okay, and generally put the 10x out in front just so it doesn't get confused that we're, somehow we'd be multiplying 10x by 3x plus 5, then taking the natural log. It keeps it that it's a separate piece. We tend to put it in the front. Okay, so product rule, still our friend, still something we need to use. Ooh, look at this one. This looks like this could be fun. Okay, looks like quotient and product and all sorts of things mixed together. That's what you'd think, right? But no, because of natural logs, we can rewrite this in a nice way. Okay, this is going to turn into, and I'm just going to write what it's going to turn into, and you can pause and think about why it is this. 2 natural log 3x squared plus 5x plus 3 natural log 2x minus 4 minus 1/2 natural log 2x plus 4. Just used all my properties from the day before yesterday with this, or whatever day it was, to do this. So now I can do derivatives, and I can just do derivatives nice and easy. So 2 fraction plus 3 fraction minus 1/2 fraction. And what goes in the fraction? Well, on the bottom is u. And on the top is u prime. 6x plus 5. 2. 2. Okay. So then we'd just make it simplified. I don't know, I'd probably go 12. I don't know, either 2 times 6x plus 5 or 12x plus 10. I don't know which way I'd go. I guess I went that way. Doesn't make much difference, really. Plus 6 over 2x minus 4 minus 1 over 2x plus 4. Okay, half of 2 is 1. So there you go. Okay, so this looks like it could be a bear, but because of natural logs and its properties, it's just a matter of doing 3 simple u primed over u's and its little simplification step. Okay? Oh! Remember this? Implicit differentiation. Couldn't hold it long enough to spell it out. Okay, implicit differentiation. So this is the y prime thing. So derivative of x squared, 2x. Derivative of 3 times the natural log of y is going to be 3 times y primed over y. Derivative of y squared is going to be plus 2y y primed. That's going to equal 0. Remember our mission on these is to get the y primed by itself so we can figure out what y primed is? Yes, that's what we're going to do. So let's see, what's this going to turn out to be? I would say I'm going to do this in a fast sort of swoop. 2y minus 3 over y equals negative 2x. Slow it down, pause if you need to. Work through that. Ask the question if you need to. Boom. 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 Okay, implicit differentiation. Get a video for that if you need it. So you're just including the y primes, getting all the y prime terms together, the not y prime terms together, factoring it out. And once you factored it out, we're trying to figure out what y primed is, so we just divide by the parentheses stuff. Implicit differentiation. Still hanging around. Logarithmic differentiation. This one is crazy. Okay, we're going to go at it. So what we do with logarithmic differentiation is we take the natural log of both sides. So I get the natural log of y equals the natural log of x squared times 3x minus 2 to the 1/2 over x plus 1 squared. Okay? And then I use my properties of natural logs to make this into a nice equation. Let's go with 2 natural log x plus 1/2 natural log 3x minus 2 minus 2 natural log x plus 1. Okay? And so then I just do my derivatives. So the derivative of the natural log of y is y primed over y. And here I get 2 times 1 over x. And here I get 1/2 of 3 over 3x minus 2, just using the u primed over u thing, minus 2 times 1 over x plus 1. Okay, we don't care what y primed over y is. We want to know what y primed is. So y primed is equal to y times all this stuff. I should copy that. Okay. Feeling like I don't want to. I can't do that. I copy all of it. Alright, so I could have just done it by now, but anyway. So y times 2 over x plus 3 over 2 times 3x minus 2 minus 2 over x plus 1. And what's y? Well, y is all of this stuff here. So if I took all of this stuff and plunked it down in front of it, we would be in a fine predicament. We'd have y primed all by itself just in terms of x's. Okay? So I'm not going to write what y is because it's just sort of monkey work. Logarithmic differentiation. New little tryst, but still derivatives. Okay? That's what we're going to be working on in class. And there's that. There's that. So the big thing to remember, go way back to the beginning. is this. U primed over U. Put the smiley faces around that so we remember. U primed over U. Okay, that's what the derivative of the natural log of anything is. U primed over U. All right, so I think we're good. Thanks for watching. Thanks for listening. Thanks for paying attention. If you have questions, you should ask. If you learned something, we'll see you soon. Bye-bye.